student, today you are going to learn the topic known as Kirchhoff's law, or you can say Kirchhoff rule. Kirchhoff law or Kirchhoff rule is subdivided into two law. It is said to be law 1 and said to be law 2. Law 1 is said to be KCL, which means Kirchhoff's current law, and second is said to be KVL, which means Kirchhoff's voltage law, which is also known as loop law or mesh law. So this is Kirchhoff current law, KCL. This is Kirchhoff voltage law, loop law or mesh law. Now you are going to understand each laws one by one. First you will understand what is Kirchhoff current law, KCL. Kirchhoff's current law. Kirchhoff's current law, that is KCL. For understanding Kirchhoff current law, let us take a junction, and this is a resistor. Through this junction, another resistor. Take number of resistors through a junctions. Let name this resistor R1, R2, R3, R4, R5. This is said to be junction. Let us connect these junctions R1, R2 and R3 with some input current. So this is I1 current entering, I2 current entering, I3 current entering. Let leaving current is I4 and leaving current is I5. So entering current is I1, I2, I3 and leaving current is I4 and I5. According to Kirchhoff current law, the sum of current entering a junction is equal to the sum of current leaving the junction. This means that sum of current entering a junction is equal to sum of current leaving the junction. This is said to be Kirchhoff current law, KCL. Here this statement means that I1 current, I2 current and I3 current are entering current, and I4 current and I5 current are leaving current. So sum of entering current is equal to sum of leaving current. You can also write this equation I1 plus I2 plus I3 plus minus I4 plus minus I5 is equal to 0, and this line is said to be summation I is equal to 0. This means that the algebraical sum of current at the junction is 0. This means that the algebraic sum of current at the junction is 0. You can write the statement like this also. Now you are going to learn that in which law this Kirchhoff current law is based. For that we know that current I is equals to Q by T. But you know summation I is equal to 0. So I is equals to Q upon T equal to 0. This means that summation Q equal to 0. Integrating we get Q is equals to constant. This means that this is based on law of conservation of charge. So we can say that KCL is based on law of conservation of charge. Law of conservation of charge. Now there is sign convention for KCL. Sign convention for KCL. Sign convention for KCL is entering current is taken as positive, then leaving current is taken as negative, and vice versa. This means that entering current is taken as negative, then leaving current is taken as positive. Sign convention is entering current is taken as positive, then leaving current is taken as negative and vice versa. This can be used as, suppose you are taking entering current as positive, that is I1 plus I2 plus I3 positive. Then you take leaving current as negative. This means that minus I4 minus I5 equal to 0. So again you get I1 plus I2 plus I3 is equals to I4 plus I5. So sum of entering current equals to sum of leaving current. But you have to write, if you use current sign convention, then you have to write this format. This is said to be KCL. Now you are going to see the next law known as current voltage law. Kirchhoff voltage law, KVL, Kirchhoff voltage law, KVL, or mesh law, Kirchhoff voltage law or mesh law or loop law. This law says that the product of current and resistance sum across a junction is equal to the sum of EMF across the junction. This means that IR1 plus IR2, I1R1, I2R2 dot dot INRN is equals to E1, E2 dot dot En. This is said to be Kirchhoff loop law. The product of sum of current and resistance across a loop is equal to the sum of EMF across that loop. This means that you have E1 minus IR1 plus E2 minus I2R2 dot dot En minus INRN is equals to 0, and this means that E1 minus V1 plus E2 minus V2 dot dot plus En minus Vn is equal to 0. This means that this is delta V1 plus delta V2 plus dot dot delta Vn equal to 0. This means that delta V summation equal to 0. Thus you can say that the potential difference algebraical sum across a loop is 0 in a single line. So you can state it like this also: the algebraical sum of potential difference the algebraical sum of potential difference across a loop is 0. Across a loop is 0. So this is said to be Kirchhoff voltage law, or you can say it is KVL. This can be understood by a circuit diagram. So let us draw a circuit diagram here. This is a circuit diagram here, battery, resistance, here again a resistor, again a battery and a resistor. This is A, B, C, D, E, F, plus minus, minus plus, R1, R2, R3, EMF E1, EMF E2. To understand this KVL, first you have to understand sign convention of KVL. Let us understand sign convention of KVL. This states that if I take a resistor here, A and B are the two ends. Current is moving from A to B. So this is current I. This is the DOC, direction of current. Let you move from A to B. That is DOT. You move from A to B and current is also moving from A to B. This means that both have same direction. Then you take plus IR as the resistance and current product. This is number first rule. Number second rule. This is a resistance R. Current is moving from A to B. So this is said to be current I, DOC, direction of current, but you are moving from A to B. You are moving from A to B, that is direction of traversal is this side, here it is this side. Here you have same direction, then plus. Opposite direction, then you write here minus IR. This means that if I say that from this plus charge current I1 is moving from this side, this is I2, then in this junction FE, in FE, if I said FE, then I am going from F to E and current is also going from F to E, then I2 into I3 is taken as positive. If I said I am going from E to F, current is coming from F to E, then I2 and I3 product is taken as negative. When I solve that question, then the points are very clear to you. Number third, here we have a battery source minus plus EMF. Suppose you are moving in this direction, DOT, direction of traversal, from minus to plus, then you take plus EMF. Number fourth, here we have a EMF source, minus to plus EMF. You are moving from minus to plus, then you take minus EMF. This means that if you are going from F to E, then EMF is taken as positive. If you are coming from E to F, then EMF is taken as negative. This rule will be only applicable when the equation should be like this: I1 R1 plus I2 R2 plus dot dot IN Rn is equals to E1 plus E2 dot dot En. This means that the product of resistance and current will be one side and the sum of EMF will be another side. If you take this type of format, then only you are using this sign convention. Format change, sign convention changes. Now let us apply this sign convention and determine the equation in this diagram. What question says? Question says that determine the equation. Determine the equations from this diagram. So you first of all I use a KCL, Kirchhoff current law. The Kirchhoff current law says that current from this positive side is coming. This is I1, and at this junction the current is divided into two parts. Let this current is I2, so this is I3. Now I2 current from A to F, F to E, E to D, this is I2. From A to D, this is I3. These two current added up here, I2 plus I3, to give you current I1. So I1 current in this B to C to B. So this is said to be KCL, use of KCL. So according to KCL, what you have? You have I1 equals to I2 plus I3. Current entering is equals to current leaving. Now use KVL in loop. Loop is B, A, D, C, B. When you move from B to A, no resistance is there. But when you move from A to D, resistance R2 is there and current I3 is here. Both have the same direction. You are moving from A to D and current is also moving from A to D. So current and resistance product is positive. So I2, I3 is positive. Right on the LHS side, I2, I3. I2, R3. I2, R3 positive. Now from D to C no resistance, but from C to B resistance is R1. Current is moving from C to B and you are also moving from C to B in this loop. Both have same direction. So again you take positive. This is I1 current and I1 R1 resistance. So right here I1 R1. Now the second chance for EMF is from A to D no EMF, D to C no EMF, C to B EMF is there. When you move from C to B, it will come from minus to plus, so you write plus E1. This is equation number 1. This is equation number 1. This will be equation number 2. Use KVL in loop. This loop, use in this loop. Loop is A, F, E, D, A. Now when we move from A to F, no resistance is there, but we move from F to E, resistance R3 is there, so I2 R3. I2 R3, you are moving from F to E, so your direction is F to E and direction of current is also F to E, so take it positive. So you have I2 R3. When you move from E to D, there is no resistance. When you move from D to A, the resistance is R2 and current is I3. You are coming from D to A, but current is going from A to D. So you have to write negative, minus I3 R2. Again, when you move from F to E, you have a EMF minus to plus. So you write diagonal side, that is E2. Question number 3. So these are the 3 equations which you have solved using KCL and KVL, that is Kirchhoff current law, loop current law and Kirchhoff voltage law. In next video you will see numerical, how to use this KVL and KCL in different type of numerical. Thank you.